Good morning, everyone. We spent about 30 minutes to get everybody started with the course. I'm looking at the class roster, and there are more students there than are logged in today. Those of you who registered for Math 130, Section 10213, I'm your instructor, Mehdi Mirfattah. You're required to be here every Monday and Wednesday at 8:30 to prepare for the class. I'm going to record a portion of the lectures every day and post it in class. You can refer to it later in time. For now, I want to make sure everybody you understand that I'm recording this session, and a copy of this will be available for everyone to view later online. So those of you logged in, please put a check mark in front of your name, confirming that. Use this time to time to make sure that you are logged in and you're okay with my lecture. So I'm waiting for all the students to place a check mark in front of their name now. For those of you not here, if you don't log in Wednesday, if I don't hear from you by end of tomorrow and don't log in Wednesday to this session, you would be dropped from this class. You're supposed to be here every Monday, Wednesday to go over the material you need to know. This is a very intense class. Every Friday we're going to meet on campus. Date and location of those are posted in your syllabus. And by now everybody should be done with a good portion of the assessment. Most of you here logged in today are done with that part. And when you're done with that, you should view all the links under the resources. There are a few video clips that would help you to understand what portion of the pie you need to complete by each Friday. You need to visit Math Success Center once a week. You can do that every Friday to complete the 5 workshops are required for this class. I'm going to talk about more of these this coming Friday when we meet on campus. Once you're done with the portion of the assessment, you should complete the take-home test, which is posted in class. The solution of the take-home test is also posted in class. We're going to review that every Friday, and also we're going to review it every Monday, Wednesday to prepare for the exams. There is a link that explains when you do the problems under the pie. Try to avoid clicking on that link. Every time you click on that, the program will generate more problems piled on your pie to complete. So it's better to not click on that so often. Instead, open the ebook, open the resources under the resources link, which are video lectures, more video lectures from the YouTube. So those are the one that you want to explore first. Your best resources would be your ebook. When you review the ebook, you would see embedded videos next to most of the topics. So before you even start the pie, you should browse the ebook carefully. Grab a notebook, assign a notebook just for this purpose. Take notes from the ebook and view the lectures that you feel that you need to explore before you even start working on the pie. Take a look at the link under the resources, video by sections. There are videos for each section of the book that are very helpful. So at this point, I want to know if there is any questions from anyone who logged in. Oscar, I see you logged out and logged in. You want to put the check mark in front of your name. Okay, so I'm going to give a minute for everyone to see you have any additional questions so far. We've been talking about all these for past 30 minutes. But since this is a recording at this point, and other students may have the same questions you have. So let's see. Ivan, go ahead and what's your question?
Yes, where exactly is the class at, like on campus?
If you take a look at the if you take a look at the class calendar under the syllabus, it has all those information. But we are going to meet every Friday in room D as David 135 at 8:30 sharp. Okay?
Okay.
And then we do log in online. Okay. Another question. Nisha? Mal?
Do we print our practice notes from Alex?
Okay, can you repeat your question one more time, please?
Do we print our practice tests from Alex?
Oh no, you don't have to print anything from Alex. As you complete the assignments in Alex, the program will report to me how many minutes you spent on each activity and what score you received. You actually can do the same. If you click on the report, you can see what portion of the problems you completed.
Yes, I know. I'm familiar with
Alex has a really good report. Very good, yeah. So you don't have to print anything. The only thing you have to print is a take-home test. And once you're done with the problems and the take-home test, you view the solution to the take-home test and you bring that on the day of
Yeah, that's what I'm talking about. Where do we print
each
that from?
on-campus meeting on Friday. Okay?
Where do we print that from?
You're talking about the take-home test?
Yes.
Yeah. If you look under the if you go under the resources, under the resources you see a link to take-home test and solutions.
Okay.
And then there's one link show you the actual take-home test, and there are several links with different formats. You can see the solutions to that.
Okay, thank you.
Okay. Sure. Okay. Before I pause the recording, are there any other questions? You can give a little feedback with your microphone, Sonosha. Okay, Sonosha, I'm sorry. You turn off your mic. Thank you. Okay. Are there any other questions, anyone? Before I pause the recording at this time, I think that was enough information for those of you not here. Like I said, if I don't hear from you and don't see you online next Wednesday, you will be dropped from class. When you log into the page to log into online session, there is a live chat I added into that page. If there's emergency or if you really need help, you can click on that at any time and you can get back with me live that way. Okay. Any question, anyone? No? Okay. So what I want to do, I'm just going to clear your check mark right now and just give me an idea as how many of you are done with the assessment. So those of you who completed the assessment, only put the check mark in front of your name. If you're still working on the assessment at this time, I want you to put the X in front of your name. That gives me an idea as how long should I need to wait until I start my lectures for chapters R and 1. That's what I'm going to work on today. So if you're done with the assessment, check mark. If you're not done with the assessment yet, put the X in front of your name. And at this point, I'm going to pause the recording, and when I start lecturing, I resume. Okay, so we're all working on the assessment now, and most of you are done with that. Question came out: what portion of the pie should be done with? Well, for the first test, which is coming this Friday, and looks like the first 3 slices of the pie is the one that you need to complete. That reflects the material for chapter R1 and 2. So that, and then you see those dotted line you see on that slices are the one that indicates what portion you completed, and that dotted line moves. And you see completely green, it means you're done with all those topics. Another thing you want to do is time to time take a look at the report and see for each session that you work on, it shows how many hours you spent, and also it shows how many objectives you completed. That's even more important. So you want to complete as many objectives as possible during the session that you work on the pie. Okay. I hope that answered the questions. So before I pause the session, are there any other questions so far, anyone? Maybe your question will be the same as the one who are viewing this recording later? No? Okay.
I have a question.
Okay, yes please. What's your question?
On the syllabus, where do our participation points fall under? Like, I see the category, so which one does it go under?
Attendance.
Oh, okay. That's it. Thank you.
It's the same as attendance. That's part of the attendance. Sure. Okay, so let's see. There's another question here that is somebody's typing here, Irene. It says, so are we working on the pie during class or just listening to the lecture? And then, yes, well, what I suggest is before you work on the pie, to be really efficient with this, is to open the ebook, read through the material from the ebook for chapter R1 and 2, and start taking notes and view some of the embedded videos, and take a look at under the resources. There are some videos per section. Those are the good ones to view. So it's all depends what topic you're working on. If you're very weak with factoring, I don't suggest you jump on the doing the problems under the pie on factoring. You need to prepare yourself. You need to look at those lecture notes before that. But if those stuff are review for you, just go jump in the doing the problems under the pie and complete them. So it's really up to you as if whether you need to view the lectures first or do the pie, or vice versa. Did I answer your question, Irene? And he said yes. Okay. So I'm going to pause the session, this recording again, until I find more important information to record. Okay, everyone, we're going to review what we have in Chapter R. Chapter R usually supposed to be, most instructors skip Chapter 1. We don't even talk about it because it's stuff from beginning algebra. But portion of this, I think, is worthwhile looking at. As you see, they're talking about study scale. You can omit that section. It's not going to be part of the test, but it's very good information. Information there you can view, not for the test. Set of numbers and interval notation, and we have operation on real numbers and simplifying algebraic expressions. As you see by these topics, these are the stuff that you're supposed to know when you enter this class. What I'd like to talk about more today from this part is interval notation, because I see a lot of students, when you get to the interval notation, they're not sure what it is. At any point, anyone here have any questions, you can go and put the X under your name or just grab a mic and talk. So let's go to the different page of this. The set of real numbers, inequality, interval notation. Again, I'm going to more talk about the interval notation because that would be a part of what you're going to see the most for the first exam. But just to quick review on the numbering system, you need to know, which is right here. Okay, we see that we're dividing all the numbers, all the real numbers, into two sections here. We have rational numbers and irrational numbers. Now, rational numbers, if you look at natural numbers, start from 1, 2, 3. These are like the whole numbers here. These are the ones that we're talking about here. These are the whole number. And the next one are whole numbers. Whole numbers would be natural numbers including 0. So set of whole numbers would be 0, 1, 2, 3, 4. So as you see, 1.1 is not part of the natural numbers. It's not part of the whole numbers. Integers would be the numbers includes the 0, include all the positive number, and also include all the negative number for integers. And the rational numbers like 0.25, 0.33333. This bar means that 3 repeat itself. So the difference between rational numbers and irrational numbers would be when this digit here, right after decimal points, repeats itself or terminates, goes to 0. The remainder becomes 0. So 1/2 is rational numbers. Irrational numbers, the classic example of that would be pi. The number after decimal points never ends, never stops, never terminates, doesn't repeat, it just go up or down rationally. The square root of prime numbers, like square root of 2, square root of 15, these would be example of irrational numbers. Other than these examples, the rest are rational numbers, and they all are part of the whole numbers. Okay. So if you have, again, if you have any question or any of these, you can jump in and ask. Now, when we talk about inequality, you should know how to show like A is less than B. That's a symbol we use. Or A is greater than B, or A is less than or equal to B, and so on. So this would be approximate, not equal to. So these are the ones. And we should be able to compare two numbers on the number line, which one is larger. So since in this case -2, the one are closer to 0 are larger. So -2 is larger than -5, so you put -2 is larger than -5. So this would be the way you compare. You can compare fractions the same way. You can use the same LCD for both of them. So in this case, LCD is 7 and 5 is 35. If I multiply the first fraction by 5/5, and then multiply the second fraction with 7/7, we get 35 here. So in that case, we can compare. Anybody know the quickest way to compare these two fractions if I didn't want to change it to the LCD? Anyone in the forum know? What's the quickest way to do that? Ray? Ray says cross multiply. Yeah, very good. If you cross multiply the numbers, you go 4 times 5 and place the number right on top of it. 4 times 5 is 20, and 3 times 7, 21. So 21 is larger than 20. So that's how you can find which one is larger. Cross multiplying is a shortcut to see if two fractions are larger. Okay, interval notation, that's the one I like to talk about more today. So when I have to graph a set of a number in the number line and express it in the interval notation, so if I have this means set of all the number x such that this symbol means such that x is greater or equal to -2. So we locate -2, and we use brackets means we want to include the endpoint. So when it says equal to, we use brackets. If you don't want to include the endpoint, you use parentheses. So all the numbers are larger than -2 would be all the numbers to the right of 2 then, like that. So this would be a graph of that. Now this is the interval notation. On the first test, you would see that they want you to write the answers, the final answer in interval notation. It's very simple notations here. So use brackets, -2 all the way to infinity, and use parentheses because the endpoints is not defined here. So that's why they use parentheses there. Are there any questions as how to write this set of inequality into interval notation so far? It would be good. Okay. So on this one here, another example, p such that p greater than -2. So you locate -2. This time you're going to use parentheses for graph. All the number larger than -2 would be to the right of -2. So the interval notation would be parentheses, -2, comma, infinity, parentheses. This is the interval notation they're referring to. Okay. Let's take a look at this one. Z such that z is less than or equal to -3/2. So locate -3/2. All number less than that would be to the left of this. Use brackets because they do have equal sign here. So the interval notation will look like this. Parentheses, -infinity, comma, -3/2 brackets. So all the number from -infinity to until to 3/2, including 3/2, would be the one that you need to include. Another interval notation. All the numbers between -4 and 2. So you locate -2 and 2. Use brackets for 2 because 2 is included at the end. Parentheses to the other side because -4 is not included. So the interval notation would be parentheses -4, comma, 2 brackets. That's how you show that. So you can just more examples. So interval notation, graphing. This means all number larger than 2 would be parentheses a, comma, infinity. All the number less than a would be -infinity a, parentheses. All the number between a and b, use a parentheses since the endpoints are not included. Now in this case, 2, all the numbers between a and b, b is included. Sometimes you use a little hole and fill out the hole instead of brackets, and then use a hole and don't fill out the hole instead of parentheses. Just different way of representing the graph. These would be the different examples. Do you have a question, anybody?
Professor?
Yes, please.
Are you answering the questions in the chat? Or are you going to only answer questions through the mic? Because I see people have questions, and I think a lot of people have the same questions.
Oh, thank you so much. I didn't mention. That's a good idea. That's why when you put a question in the chat, please put the X front of your name. or also get my attention by clicking on that little icon, raise your hand, because it does make a little noise for me. Okay, so yeah, thank you. Here is a question from Margarita. It says, I don't understand when to add brackets. Okay. You use brackets if it is equal to. Okay, that's it. When the endpoint is included. So let's go back to that example again. So this would be a good example probably. You see how we're showing all the numbers between -4 and 2, but 2 is included because it's equal to, but 4 is not, -4 is not included because it doesn't say equal to here, right? So in this case, I use parentheses here because -4 is not part of the solution. However, I use brackets here because 2 is included. So Margarita, do you follow that now? Do you understand how to use brackets and parentheses? Is it not completely? Okay, so let me show you more examples. Let me see if anything else I want to show on this one. Okay, I'm going to go ahead and stop this. Okay, I'll show you more examples to illustrate that. So let me go ahead and grab my notepad, new page. Okay, so interval notation. So let's say we want to know all the numbers that are between, let's look at the graph first, probably it's easier. Okay. Zero, 1, 2, 3, and on this other side, integers, -1, -2, -3. Okay, so let's say we want to have all the numbers between -2 and 3. Like I said, some people show it like this. They show a little hole there, like this. All the numbers are between these two. Okay. Again, sometimes they show the graph like this. These are the same graph. Okay, they use brackets, means the endpoint is included, parentheses when the endpoint is not included. -2, this is 0, this is 3. Now that's all it means. We're talking about all the numbers that are in between -2 and 3, but the 3 is included as part of the answer. So if I were going to write the set of the numbers, Yvonne, you can go ahead and what's your question?
So which one would you rather us do, the brackets with the parentheses or the close and open?
I would rather you to use the brackets and parentheses, since in this book that's how they represent it. But I've seen this configuration before as well. So, but okay, you should use this one here. But I'm showing you that, so if you see it in somewhere else, you understand what that means. So if I were going to show the set of the numbers here, we're talking about all the numbers between -2 and 3. So this is the set that they're talking about here. -1, 0, 1, 2, 3. Then -2 is not included. So the interval notation would be -2, comma 3, and then brackets. That's what it is. So let's see. Margarita, I think, was asking that question. Margarita, do you understand that now? Interval notation. Do you get it? A bit better yet. Okay. So basically, that's all it is. This is just called interval notation. So on the test, you would see the question, write the final answer in interval notation. So this is the notation they're referring to. This would be another notation, but that's not the interval notation. Okay, so that's pretty much what chapter, or in addition to what is important in section R. So chapter R is basically knowing how to add and subtract, multiply, divide real numbers. And I've seen in past some students have a problem with finding the LCD still, adding fractions. So you really need to refresh, and that pi section that you're working on actually is a great way to master those topics, because they don't let you move on until you know how to do this stuff before they open up the sections for chapters 1 and 2. So you really need to work on that. So what I like to do is, after the break, talk about a little bit of what's going on in chapter 1, and also show you the take-home test number 1, and make sure we know how to work on that. By next meeting, you should be done with chapter R, chapter 1, and most part of chapter 2 as far as the ebook concerns. Review them so you can make a list of your questions so you can ask. Okay. Are there any questions so far on what we're doing? Okay. Okay. So this one is question. Yes, Tony?
Yes, I had a question about the equation you just showed us. The 2 isn't in the equation because it's less than, or why isn't it in the equation?
You're talking about the one that I have on the board right now?
Yes.
Okay, say your question one more time.
Because in the interval equation, why isn't the 2 in there? I had a little bit of concern right there.
You mean the -2?
Yes.
Why I'm using parentheses for -2, you mean?
No, to the right.
Oh, you're talking about this set here.
Yes.
Okay, because we're looking at the whole numbers, all the whole numbers between these two, not all the real numbers. So -2 point something is part of the real numbers, but not the whole numbers. So when talking about the whole numbers, we're all talking about like 1, 0, -1, 0, 1, 2, 3. Just the whole number.
Oh, okay.
Okay, so this represents the whole numbers.
Okay.
So natural numbers and whole numbers, integers. So we're talking about the integer. If you talk about the integers, then 1.1 is not included as part of the integers. That's part of the real numbers. Okay?
All right, thank you.
Sure. Okay, what I'm going to do is I'm going to grab actually the take-home test number 1, and after the break, pick some problems from that is related to interval notation to just point at what I mean by showing this in interval notation, be a little bit more clear also, and browse through the stuff for chapter 1 as well there. But I want to make sure, are there any questions so far, concern, comments? Now is a good time. A few minutes before the break, we can look at that. Any questions, anyone? Okay, so just get everybody gather all the information together and all that. I would like everyone to print take-home test number 1 if you can. Bring it after break, and if you don't have a printer available, just make sure you have it up on your screen, so when I refer to them, you know which problem I'm talking about. So since you have to do a little bit more work, so let's get back here at 11 o'clock. You have a question? Yes, please. Sue. Go ahead. What are you typing? Where is the test is located? Under the resources, okay, there is a link says take home test and solutions. Do you see that? Okay, I'm going to the Alex myself. Okay, you see it. Okay, good. All right. There's a blank test. Also, there's a link to the solution. Very good. Okay, so let everybody take a break until 11 o'clock. 11 o'clock. We'll be back at 11 a.m. Okay? All right. Have a good break. We'll see you at 11 o'clock. Okay, I'm back recording again after a break. Everybody should be able to view the PowerPoint from chapter 1 now. If you have any problem viewing this, please put the X in front of your name so I can help you with that. You should be able to see that. Okay, for chapter 1, as you see here, we are looking at linear equations in one variable. Now, these are the titles you look for under the pie that you need to complete. That was a question earlier. And then we figured it looks like the first 3 slices of that pie need to be completed, which includes chapter 1 and 2. So here we are talking about linear equations in one variable and some of the applications of that, and in inequality. So let's take a look at some of the examples here. Let's start with very simple problems here, how to solve a linear equation. The linear equation format looks like this, and you have ax plus b is equal to c, where you need to solve for x. So there are some properties that we can use to do this. So addition property of equality, subtraction property of equality. This stuff should be also reviewed for most of you. You're allowed to add or subtract same number to both sides of the equation to isolate the variable. Okay. And then if you have a, let's take a look at some examples here. Now, this would be a good example here. Solve the equation here. We're solving for p. In order to eliminate this number here, well, we cannot use any of the other property we just looked at. This would be to eliminate this coefficient. Can somebody tell me in the forum how to eliminate that minus 3/5? What do you do?
Cross multiply?
So you multiply both sides of the equation by reciprocal of this. So the reciprocal of minus 3/5 is minus 5/3. Because every time you multiply a number of times reciprocal, it results into 1. You see, that's what you want. You want the coefficient of p equal to 1, so then you reduce. And you see the solution, they're showing the solution as in the set. There's only one solution here. Why do we have only one solution? How come we don't have 2 or 3 solutions here, anyone?
Because of because
there's only one variable. So then there can only be one.
Well, so
one solution would work.
Yeah, it's only one variable, but what about that variable? The order of that variable is important. What's the order of this polynomial? Order is exponent. So because p is to the power of 1, that's why we get one solution. If you had p to the power of 2, you still have one variable, but if you still have p to the power of 2, then you expect to get 2 solutions. That would be a second order polynomial. Okay, so keep that in mind. So let's take a look at oops, we got there we go. All right, let's take a look at more example. I just lost my page for a second. So this would be another example. Solve 4 is equal to W over 2.2. So what is the coefficient of W here, anyone? What coefficient means a number that multiplies a variable. What is the coefficient of W?
1.
Okay, anyone else? Is that 1, really? Okay. Irene says 2.2 with the question mark. The coefficient of variable is not 1, it's not 2.2. Anyone else wants to try that? Yes, Irene typed 1 over 2.2, exactly. The coefficient of variable is 1 over 2.2. That's why the reciprocal of 1 over 2.2 is 2.2 over 1. You see how we multiply both sides by 2.2 over 1 or 2.2? That's how you eliminate these 2.2. So you multiply both sides by reciprocal of 1 over 2.2, which is 2.2 over 1. Any question so far? Okay. So let's take a look at more examples here. Here we're going to solve the linear equation. Linear equation because we don't have a square or cubed here. That's what we call a linear equation. You only have a power of 1 here. So that would be a good example of using those two properties we looked at earlier. You subtract 1 from both sides of the equation and divide both sides by 3, or multiply by reciprocal of that, which is 1/3. Okay, anytime if you don't follow any of these examples, please raise your hand or get my attention, please. All right, next one. We can always check our answers to see if that indeed is a solution. You substitute for each x minus 8 over 3 and see if it's true. So in this case, it's true. That's how you solve linear equations, simple linear equations. Now this would be the one that requires a little work here. What would be the first step here, anyone, to solve for this?
distribute the 5 to the z and the -2.
Very good. So you distribute the 5, you get 5z minus 10, and then you combine like terms, and then you start isolating the variable z by adding -2 to both sides of the equation and dividing both sides by 6, and that's how you get z is equal to -2. Okay, everybody okay with that? And we can always check our answers if that indeed is the solution. All it is. So solving linear equation should be pretty simple. You can check the answer that way. So this would be another example here. It requires a little bit more work here. We distribute -3 and 2, and then we distribute -4. You see, we use an order of operation. We work from inside out. So you distribute -3 first, combine like terms, and distribute -4. You distribute 2 at the top, at the right hand side, combine like terms, and then you solve for y. And then we divide both sides by 18, and 4 would be your answer. Okay, are there any questions on how to solve linear equations in one variable? Everybody okay with that? Now, there are different type of equations here. Now, this is solve the equations. As you see, we have fractions here. What do you think you're doing here? What are the steps you're taking to eliminate the fractions, anyone? And I'd like more of you contribute to the discussion. Talk about it. Okay, I'm sorry, say that again?
Common denominator. Multiply by the common denominator.
Right. You find the LCD. You find the LCD, which is among all of them. The LCD between 4, 3, and 2 is 12. So you multiply each term by 12. So make a note of that, everyone. Every time you see an equation involving fractions, you multiply each term by LCD. Here, if I multiply 12 by this, it becomes 12 over 4, which is 3. If I multiply the second term by 12, 12 times 1/3 is 4. Multiply 12 by the next one, becomes. Somebody has a question?
Yeah, if you take the 1/2 in parentheses w -4, would that be, how would you divide w into a half?
Okay, you're talking about this portion here, 1/2 times w, this one here? Okay, so when you multiply 1/2 by w, you just write as 1/2 w, and then when you multiply it by 12, then you eliminate the fraction, because 12 over 2 is equal to 6. Do you see that?
Okay, yeah, I see it, thank you.
Right, so the first thing you do is you multiply each term by LCD, and that would guarantee to get rid of all the fractions. So some of these numbers becomes larger number, like this were -2, when you multiply by 12 becomes -24, that's okay. But now we don't have any fraction, we have a linear equation with no fractions there. So are we okay up till this point here? We get 3w plus 4w minus 12 is equal to 6w minus 24. Okay, so in this case, we'll combine like terms. You get 7w minus 12, and then you would subtract 6w from both sides of the equation. You add 12 to both sides of the equation. You get w is equal to -12. Okay, again, stop me if you don't follow any of these, so we can look at it in more detail. Question on how to eliminate the fraction, anyone? Now, these stuff here are in your ebook, so that's what I like you to, like when you prepare for chapter 2, that's what I want you to do for next meeting. Take a look at the questions, problems from chapter 2 in ebook, And if any of them you have a problem with, you see a little video next to it, you click on it and just go over like I'm doing right now. That's how you prepare for the lectures. Now here we have 5, 2, and 10. To eliminate that, we need to multiply each term by LCD. As you see, the LCD is 10. If I multiply each term by LCD, 10 over 5, you see how that would becomes 2 here. And then here 10 over 2, right? That eliminates 10 over 2. That becomes 5, negative 5 here. Again, multiply the next each term by 10. So again, some of this number become larger, but that's okay. This was 2, now it becomes 20. So don't forget to multiply each term by LCD, otherwise it's not going to work. So this equation here, down here, is equivalent to this equation up here. That's all I did was I just multiplied each term by 10 by LCD. This is a lot easier to deal with. So that's all I need to do now is to distribute and solve for x. Are there any questions so far? Yes, please. What's the question? Okay, who's asking? Margarita, what's your question? Oh, you have to type. I'm sorry. Can you please go back to the last equation? Sure. Last equation, this one. Is that the one? Or the one before that? Or the one before that, sure. This one? Yes, okay. So do you have any question on this? Oh, you want to just write it down. By the way, all these problems on the ebook, what you can do is also you can refer to, if you don't want to write everything down, you can just refer to the sections that we're working on. So this problem here that we're working on right now is, let's see what problems that. This is example 8 in 2.1. Okay, so you can refer to that way too. So if you open your ebook, example 8, you would see that. Okay, good. Yes, I would like you to learn the concept here, and then the detail we can look at them. Okay, I'm going to pause the session for a second because somebody's trying to log into the session, I believe. Let me help the student. So let me have you write this down, take a look at this. Okay, Jared, do you have a question?
So I'm trying to look at the example number 8, and I get the first part where you take the lower common denominator and you take the 10. What do you do with the 10? Do you divide them or what?
Okay, you see where this 10 is right there? Let me, okay. This 10, do you see this 10 right here, right?
Mm-hmm.
when you multiply the 10 by x minus 2 over 5, do you see that 10 and 5 reduces to 2?
Okay.
Right there. What is 10 over, what is 10 divided by 5?
2.
2. So you saw it reduces to 2, and then the other stuff still remains. X minus 2 stays here, but only 5 disappears, right?
Right.
5 cancels. Same as 2 here for the second one. 10 over 2 is 5, right?
Mm-hmm.
So that becomes 5 times x minus 4. So that's the trick to get rid of the number at the bottom of the fraction by multiplying it by LCD, because LCD goes through all of those and remain there with the remainder of 0. Right? You see how these two terms turn to
okay, yeah, I get
this.
it.
Right. The next term, we made this 2 larger, but we have no choice. We have to multiply 10 by 2, and it becomes 20, but that's part of the steps because we need to do that to maintain the same equation. And then 10 over 10 becomes 1. So you see how I got this,
okay.
right?
Yeah, I got it now. Thank you.
Right, very good. This equation is equivalent to this horrible looking one, right? This is a lot easier to deal with. Good. Okay, so you see that, and then you solve for it. You didn't have any problem solving for that, right? Very good. Okay, so these are just a few examples of, if you look at this take-home test, those of you I asked you to print it, if you look at the take-home test number 1, you should see a few problems like that, where you have to eliminate the fraction to solve for them. Okay, now this would be another example. So everybody got this, right? When you multiply that and then you solve, there you go. So then you solve for that and you find negative, so you can check the answer too. Now you do the same thing with the decimal. This would be equation involving decimal. So in order to eliminate the decimal, now you multiply each by factor of 10. Since we have two digits after the decimals here, there's only 1, but these are 2. So I have to multiply each term by 1 followed by 2 zeros, or 100. So this 100 would help me to eliminate the decimals, get it into a linear equation. Okay, that was example 9 in that section. So of course you can reduce them to minus 2/5 or minus 0.4. So basically, this is how you would solve equations. If you have a fraction or decimal, you can eliminate it. And this would be like a combination of those here. In this case, we have identifying conditional equations. Now, sometimes you have no solutions or infinitely many solutions when you look at the equations. So let's take a look at this one here. When I reduce this, when I multiply each term by -1, when I distribute this -1 here, inside the brackets I get x minus 1. And then you see x cancels. There's no more x. X minus x is 0. So you end up getting -3 is equal to -2. So this kind of equation is called contradiction. So it means there is no solution. This is how you view them. No you use this brackets with nothing in it, or contradiction means there's no solution. So you could have no solutions for the equations like that. Any question on that so far? Okay, so this one would be an example where you have infinitely many solutions. Infinitely many solution would be when you distribute and all that, all the variables cancels, all the number cancels, you end up getting 0 is equal to 0. This is known as identity. It means all real numbers can be a solution here. I can pick any number here, it works. Good example of that would be like x is equal to x, or x plus 1 is equal to x plus 1. I can pick any number I can into this equation, it would work. So that would be infinitely many solutions, or identity. So you should be able to look at the equation, solve for them, and find whether there are no solutions, or one solution like in this case, or infinitely many solutions for that. Okay. So this was the section, chapter 1. Stuff you need to know for 1.1. Okay, let me go back to so 1.1 to 1.5. Linear equation, one variable. Are there any questions so far on these? So let me show you some of the lecture notes from this section. Okay, let me upload that. Okay, let's go back to the board here quickly, make sure everybody understands the difference again. So some example here would be like this. If I have x is equal to x, okay, how many solutions do we get here? Anyone?
Infinite solutions?
Yeah, infinite, or x plus 1 is equal to x plus 1. So I can pick any number I want here and solve for x. So all real number would be a solution, or infinitely many solutions, all, or identity, all those names they use for that. All real numbers. Okay, so example of no solutions would be if I have x plus 1 is equal to x plus 2. So it's pretty obvious, right? We begin with this were an equation. We begin with 1 is not equal to 2. So how can I put add the same number to both sides of the equation here to make this equal? There's no way I can do that, right? So that would be an example of no solution. No solution. Right? Or sometimes they use brackets with nothing in it. Contradiction, all those different names for it. Okay, can somebody give me another example of no solution? Anyone? Give me another equation with no solution.
Would it be,
go ahead.
2x plus 5 is equal to 2x plus 7?
Yeah, very good. 2x plus 7, very good. So you see, 5 is not equal to 7 with begin it. How can I put same amount, 2x to both sides? That would be Irene put x. Irene put another one. Irene put this example: y minus 3 is equal to y plus 4. Would that be no solution? Well, let's solve this example that Irene gave us. So we're going to solve for this. I can subtract y from both of the equation. I can add 3 to both of the equation. So you get 0 is equal to 7. Yeah, no solution. 0 cannot be equal to 7. So that's this one. So when you get 0 is equal to 2, 1 is equal to 5, and all the variables drops, that would be no solution. Jared says, so when both variables are 0. You mean add up to 0. Is that what you mean, Jared? Yeah. When the variables add up to 0, and it would equal to, so in this example, in infinite limited solutions, the variables add up to 0 too, because x minus x, and then, but the thing is, the constant also add up to 0, because 0 is equal to 0. So in this case, it would be infinitely many solution, or all real numbers, but in this case, because 0 is equal to another number, which is not 0, then that would be the difference between no solution or infinitely many solutions. Okay, everybody okay with that now? Okay. Okay, section 1.2, we're talking about application. And if you take a look at the sample test or take-home test number 1, you see some of these word problems that you need to concentrate on. And as you know, everybody has to complete 5 DLA or workshops at Math Success Center for this class. So what I suggest is, everyone, if you have a problem with these word problems, is to sign up between now until Friday for 1 or 2 of these word problems that they're offering, and they go in detail through the steps. If you look at the ebook also, it shows you the steps as how to read the problem carefully and assign a variable and start making a model for some of them and start writing the equation and solve for them and then see if it makes sense. And there are some video embedded into each of them. It looks like some of you are chatting there. When you chat, please let me know by raising your hand so I can hear. Some of these need my attention here. So let's see. Tanisha, Jared, okay, the question is, can you do it at PCC? Unfortunately, for winter session, they do not offer workshops at PCC, only at LAC. So you need to come to LAC. You may want to come. You know, they're open Monday through Friday, I believe, to take care of this. Okay, did I answer your question? Okay. All right. So these you really can actually get into these steps very easily by looking at all the resources you have available under Alex too. But if you since you have to do 5 workshops, I think these would be the one that, since a lot of students struggling with the word problems. Now, for the beginning of word problems, you need to get yourself familiar with the words that are related to adding, subtracting, dividing, and multiplying here. So these are the phrases that they use for addition: the sum of A and B, A plus B, B added to A. So these are the, you have all this in your text too as well. You can get yourself familiar with these phrases, and then you'll see a lot of different examples on that section. Like example over here, we have the sum of 2 numbers is 39. One number is 3 less than twice the other one. So in this case, you would let something be equal to x, and Jared is asking questions says what is step 2 and 3. Well, these are just the steps that they came up with. I mean, let's look at the steps here. Step number 1, it says read the problem carefully. Okay, and then step number 2 is assign labels to unknown, whatever is unknown. In this case, you want to assign a variable to it, and then you write sometimes a verbal model, and then you write a mathematical equation for it, and you solve for it, and so like take a look at this example here. You read the question carefully, and then you let something be equal to x. Well, in this case, let x represent the number. That's the number that they're referring to. You follow that, Jared? Yes, okay. So in this case, we just basically let 2x minus 3 represent the other number, because it says one number is 3 less than twice the number. Twice the number would be 2x. 3 less than that would be 2x minus 3. So you have two numbers, x, 2x minus 3 is equal to 39. So the sum of these add up to 39. So then you solve for equations. Will you follow how to set this up? Question on that? Okay, and then you solve for a number, of course. And then the first number would be 14. The next one would be 2 times 14 minus 3 would be 25. Okay, Jared, yes, what's your question? Oh, you typed it. Okay, maybe not. You're right. Let me see what's going on here. Looks like you're saying that. Okay, let me reset this. Maybe you weren't looking at the right PowerPoint that I was showing. I'm using multiple computers here to show the PowerPoint. Okay, I'm resetting that PowerPoint computer. Okay, yeah, now you should follow me. So let me go back to the one. Here it is. So the sum of two numbers, we talk about this. You see that now, Jerry, right? Okay, good. All right, good. We resolved the problem. Okay, so here we set up that we solve for x, and then we get x equal to 14. And once you find the first number, double that, subtract 3 from that, so the answers would be 14 and 25. So that was one example of this type of the problems here. So we get to consecutive integers. You see some of these in the take-home test. You would see it on the next exam. So make sure everybody know what that means. Consecutive integers would be like 1, 2, 3, 4, 5. These are the consecutive integers. So let me go ahead and give a little bit more detail on that one. Let me stop this presentation for a second and show you some examples actually. Okay, when we're talking about the consecutive integers, it's very important because you're going to see this on the exam. If I have 1, 2, 3, 4, this is the example of consecutive integers. Okay, so if I let the first integer be equal to x, let's say, Can somebody tell me what would be the second one in terms of x? You can grab your mic and say it. Okay, Jared says 2x. Ray says x plus 1. Tony says 2x. Well, the next one should be x plus 1 then, right? Because not 2x doesn't work. How about the third one? What would be the third one in terms of x? Would be x plus what? X plus 2, right? The next one would be x plus 2. And the next one would be x plus 3 and so on, right? X plus 3. 2x won't work because if I let x equal to 1, right? 2x only may work for this one, however, it doesn't work for the next one, right? But this pattern works for all of them. If x equal to 1, if I place 1 here, this becomes that 1 plus 1 is 2, 1 plus 3 is equal to 1 plus 2 is equal to 3, 1 plus 3 is equal to 4, and so on. So this would be a consecutive integers that we're talking about. If I have odd numbers, 1, 3, 5, 7. So if I call the first one x, what would be the one after that, next to it? Anyone? Okay, looks like in the chat room everybody agree, or at least those people who are participating says x plus 2. Yes, absolutely. So how about the one next after that? What would be x plus what? X plus 4. So that should make sense, because if x equal to 1, 1 plus 2 is 3, 1 plus 4 is 5. Yeah, it works. Okay, how about if I have even? If I have 2, 4, 6, 8, and so on. If I call the first one x, what would be one after that? X plus what? Again, it's too good. The next one would be x plus 4 and so on. Right? So it looks like consecutive even and consecutive odd integers would have the same assumptions. X would be, if x is the first one, the next one would be 2 more than that. This is x plus 2. The next one would be 2 more than the previous one, and so on. Okay? So this is how you make the assumptions for the consecutive integers. Are there any questions so far? So this is how you let x equal to a number. So let's take a look at the example that we had earlier. On this one, we were looking at this example here. We have 3 times the sum of 2 consecutive odd integers is 516. 5 the integers. So in this case, we let x represent the first odd integer. So the next one is x plus 2. So now we see why this is x and why this is x plus 2, right? So we have 3 times the sum of 2 consecutive odd integers. The sum of 2 consecutive odd integers would be x, x plus 2. This would be the sum of 2 consecutive odd integers. Right? 3 times that would be times 3 equal to 560. So we made the assumptions, we made the variable, we made the equation. Now we have to solve this and see what x is. So once we do that, we find x equal to 85, so the next number has to be 2 more than that, which would be 87. Okay, are there any questions on that so far? Okay, this is another type of problem that you would see, percent application problem, when you're investing some money into one account that earns so much interest. So in this case, we have $5,000 that would earn 5 1/4% simple interest. Okay, if the money is invested for 3 years, you want to know how much money is the account at the end of the 3 years. So you let X equal to represent the total money. So in this case, the principal, the amount of money that you're investing is 5,000, and then the rate is 5 1/4, 5 1/4%, so it would be 0.0525, and the time is 3. So total money is equal to principal plus the interest. So the total money would be X equal to the P, the principal, plus PRT. That's the simple interest. Okay, so just simply substitute the numbers. So the 5,000 plus 5,000 times the interest times the time. So this is how much money we have total. The amount of money we had originally. Sometimes they only ask you to find this amount here, PRT. In this case, you just figure that out. So these are another type of interest problem here. The college bookstore uses a standard markup for 40% on the books purchased wholesale from the publisher. If the bookstore sells a calculated book for this amount, $179.20, what is the original wholesale? So X would be the original wholesales. So this is the formula. The sales is equal to original plus markup. So original, we don't know what it is, we call it X. The markup would be X times 40%. And the sale price we know is $179.20. So this is how, when you solve for X, that would be the original amount of the money that the bookstore purchased from the publisher. They buy that for $128 and they sell it for $179.20 because of the markup is 40%. Okay, so these are the kind of word problems that that you need to know. Question? Yes, please. Okay, you have a mic or you have to type? Looks like you're typing. Okay, go ahead. Those of you that have a microphone, please try to get one for the next meeting. Okay, the question is 0.4 is equal to 1.4x. Is that what you're asking? Then we'll go back to the same page. Is this the problem you're referring to? Oh, I see. You mean put X. Yeah, I think you said you understand that. Yeah. Okay. When it says 40%, just go 40 divided by 100, basically. Comes 0.4. Change it to the decimal. Looks like you said you're getting it. Okay, good. Okay, any other questions? Okay, the mixture problem are the one that you need to know. Also, there's some of them in the take-home test. So this would be a good example. How many liters of 40% antifreeze solution must be added to 4 liters of 10% antifreeze to produce 35%? So the illustration here sometimes is pretty helpful on that. So thank you for reminding.
You're welcome.
Yeah, I was. Yeah, thank you. Yeah, I wasn't recording earlier. So this is how we set up that word problem here. So in this case, we have 2 containers here. One with 40 labeled 40% right here, and the other one labeled 10%, and ultimately you want to get 35%. So it says we don't know how much we're going to use for 40%. We call it N, but we know that we only can use 4 liters. We only have 4 liters available on this container. So ultimately, we're going to get 35% antifreeze. So the amount here should be N plus 4. So that's how you set them up. So in this case, we have 40% times N plus 10% times 4 should add up to 35% times 4 plus N. So I want to make sure you understand how to set this up, first of all. Would you okay with that? I think this illustration is a little easier, better to understand than the one that the book shows, with all those cylinders stacking up. Okay? So we can set something like that for any of those mixture problems. We can actually use this for investment problem too. If you have 2 accounts to invest, you can use a similar illustration here. So 40%, if we change it to 40 divided by 100 would be 0.4 N. 10% would be 0.1 times 4. 35% divided by 100 would be 0.35 times 4 plus N. And then we solve for N. We multiply them by a factor of 10. But before I go back to the complete solution of this, can I see a check mark from everybody's name? Make sure we follow this problem here. Again, you're going to see one mixture problem on the exam. Okay, I'll wait for your response. Make sure we get this. Check mark if you don't understand it. X, I can explain it a different way maybe. Okay. Leah, are you okay? I don't see a response from you. Are you still there? Christian, are you there? Okay, you guys remember you need to participate. Okay, we're there. No, accept. Leah, are you there? Leah? Left the room? Okay, we get back to you later. So let's see. All right. So now when you see how to set this up, let's take a look at the solution again, see if that makes a little bit more sense. Okay, you see how we have here 0.4x plus 0.1 times 4 plus 0.35 times 4 plus x. Now they decided to not eliminate the decimal, that's fine. You could multiply each term by a factor of 10 to solve for x, but you can just deal with the decimal all the way to get x equal to 20. So therefore 20 liter of 40% antifreeze solution is needed for that. Okay, so another type of problems that you're going to see is distance, rate, time problem. Okay, this would be an example here. Hiker can hike 1 miles per hour faster downhill to Moose Lake than he can hike uphill back to campsite. If it takes her 3 hours to hike to the lake and 4.5 hours to hike back, what is her speed hiking back to the campsite? So in this case, this would be a good setup actually for distance rate problem. So you write the trip to the lake and return trip. You write distance equal to rate times time and start recording what we know. We know the time is 3 here, 3 hours. Return would be 4.5. And then we assume that x would be the return time and x plus 1 would be the trip to the lake, and then distance would be rate times time. So the distance would be 3 times x plus 1, 4.5 times x. So the distance is the same, so this would be your equation that you set up. And then you solve for x. Okay. This would be an example of how to set up this kind of problems. Okay. Section 1.3 deals with applications of geometry. Let's take a look at some of the examples here. One of the one that you'll see on the test is this kind. Complementary and supplementary. You will see a problem like that on the exam, and you also see it in the take-home test. So let's take a look at this example here. When the two angles are complementary of each other, means they add up to 90 degrees. If they're supplementary, they add up to 180 degrees. So here it says two angles are complementary. One angle is measured 10 less than 4 times the other one. Find the angle. So if two angles are going to be complementary, add up to 90 degrees. So we can kind of show it on this graph that we just assume one is x, so the other one would be 10 less than 4 times that. So it would be 4x minus 10. So if I add these two up, x plus 4x minus 10 should add up to 90 degrees, and then you solve for x. Now, are there any question on this kind of problem? Like I said, you're going to see this on the test. Supplementary and complementary. So let me show that on the board also, since this is important. So I'm going to give you something very similar to the one you see on the test. So let's do that. Okay, stop. New page. Okay, so one of the classic examples I usually give on the exam is this one. Okay, so you have two different kinds. One, if they add up to 180 degrees. The other one is add up to 90 degrees. Supplementary and complementary. So if I call this one x, the measure of the other angle would be 90 minus x, if you want to write it in terms of x only. If I call this x, if they are supplementary of each other, the measure of the other angle would be 180 minus x. So this is how you set them up. So one example I usually give on the exam is if I say if two angles are complementary of each other, and if one angle is, let's say, twice as the other one, what would be each angle? How do you set this up? Okay, that was a question for everyone. Who wants to go ahead? Margarita? Oh, answer the question. Okay, if one angle twice as the other one and they are supplementary. I'm sorry, they're complementary in this case. How do you find the angles? How do you set up the equation? Okay, Sue says 90 minus x plus x equal to 90. But we know one is twice as the other one. Okay, Tanisha says 2x plus x is equal to 90. Yeah, very good. Ray says the same thing. Yeah. So that's how you set them up. If one is twice as the other one, if I call this x, the other one, it must be 2x then, right? And if they're complementary, it means they add up to, if they're complementary, if this is x and this is y, they add up to 90 degrees. It's y. So in this case, this angles should add up to 90 degrees. X plus 2x is equal to 90. So can somebody tell me what's the angle? So what is x?
30.
Would be 90 divided by 3, right? 30. Okay. Yes, what's the question?
For the 180 minus x, the one at the top left, would it be x plus 2x equals 180?
Right. If they were supplementary, so let me do this then, so you won't get confused here. I'm going to do the same problem with that one, with the next page. So I'm going to do that one on the next page. For this one, if this were x and this was 2x, then if they were supplementary of each other, it would be x plus 2x must be equal to 180 exactly. So it would be 3x equal to 180. So x would be 180 divided by 3, which is equal to what? $60. So this must be 60. The other one would be 2 times 60. Right, if they were supplementary of each other. But if they are complementary, if one is 30, the other one would be 2 times 30. That would be 60. So when you get the difference between complementary and supplementary angles?
Are you going to state if it's complementary or supplementary?
I must, yeah. Otherwise,
Okay.
you won't know.
Okay.
Yeah. If you look at that take-home test, there's one example very similar to this, where it says either complementary or supplementary. Then you decide which one. Okay. Good. So it looks like you are getting that. You're already getting ready for test number 1. Question? Yes, please. Okay. The question is, complementary means it adds up to 90. Supplementary means add up to 180. Yes, that's correct. That is absolutely correct. Again, when you ready to prepare for the chapters, take a look at the ebook. All these problems we're reviewing right now, they're in great detail with the lectures and illustration in ebook. So it helps to look at them. All right, so another kind of problems that you're going to see is this kind. So if I give you an equation, like in this case we have C is equal to 2 pi r. You want to solve for r. So if you have an equation involving more than one variable, see how we have, in this case, circumference of the circle is equal to 2 times pi times r. If we were going to solve for r, that's all you do is you treat the other variables as a constant or a number. So divide both sides here by 2 pi, and that's how you isolate r. So that's how you solve r in terms of the other variable. So r is equal to c over 2 pi. Any question on that? And then you plug the numbers in and you solve for them. This would be a classic example of formula solving one variable in terms of the other one. If there's a formula, we want to find the area of a trapezoid is given by A is equal to 1/2 B1 plus B2 times H, where B1 and B2 are the length of the parallel side of H is the height. We want to find or solve the formula for B1. So in this case, you would solve for B1. You need to eliminate anything attached to B1. The first thing I can see attached to B1 is 1/2. So if I multiply both sides of the equation by 2, I would get 2A is equal to B1 plus B2 is equal to H. And then I need to distribute here and then move the one term that I don't need, which is namely B2, to the other side of the equation. and then divide both sides by the coefficient of B1, which is H. That's how you isolate that. So you find B1 is equal to 2A minus B2H over H. Now, are there any questions on this type of problem? If you do, write on the board. If you're okay with them, we'll move on. Now would be a good time maybe to ask if everybody okay with what we're doing so far. Question on these so far? Yes. Okay, sure. So let's look at this on the board. Or look at this a little bit slower, because this is also a very important problem. We're going to see this on the test. So I'm going to write down the formula here, put it on the board, and then go over it in detail. Okay, let's do that. So we'll stop this. Go back to my board. New page. Okay. So this is what we have. We have A is equal to 1/2 B1 plus B2 times H. Your audio. Okay, is audio okay now? Yes, okay, good. All right, we want to solve for B1. Let's solve for B1. Doesn't matter, B1 or B2. Solve for B1. So the first step is to eliminate that 1/2. To eliminate this 1/2, I can multiply both sides of the equation by a reciprocal of that, which is 2/1. So I would get this. So we get 2A is equal to B1 plus B2 times H. So let me ask at this point, put the check mark in front of your name if you're all okay with this all up to this point here. Check mark if you all can get it. Okay. Leah, are you still there? Looks like you're not responding anymore. Okay, Leah not there. I think maybe she left. Again, to receive credit for each session, you need to participate throughout the session. Okay, good. So looks like everybody okay with up to this point. The next step is to distribute. We get B1 times H plus B2 times H. Remember, we're solving for B1, so we need to isolate B1. So what I need to do is to subtract B2H from both sides of the equation. So on the left-hand side, I would get 2A minus B2 times H is equal to B1 times H. So to solve for B1, that's all I have to do is just divide both sides by this coefficient. And there we have it. Then we get B1 is equal to 2A minus B2H over H. Can I simplify this? Can I reduce anything? That's the question. Okay, who wants to answer that? Okay, Tony says H. I don't know what that means. Tony says no. H. Okay, so you agree. Tamisha says yes, no. Okay, so we cannot, in the chat room, they're torn between eliminate the H or not. Some of you says no, you can't. Few of you says yes. Those of you say no, you're correct, because in order to eliminate H is, if I had H here also, I can divide this term by H, but I cannot eliminate this H and H, because this H also belongs to this 2A. Right? If I separate this, you probably can see it better. See, B1 is equal to 2A over H minus B2H over H. So the H can be reduced in the second term, but you have to keep them to include it with the first term. So if I reduce this to, then I won't be able to include it with this first term. So this H belongs to the first term also. So you can either write it like this or leave it like that. It says we cannot eliminate this anymore. Okay, good. Looks like everybody getting that. Very good. Okay, looks like Leah is back. Okay, one more time, can I see a check mark in front of your name if you're all okay with this? All right. Okay, let me give you another example here. This would be where we have a formula for a volume of a right cylinder. Nobody remember that? I don't. Actually, you should. Volume of right cylinder is not that hard to retrieve, because this is the right cylinder, right? The volume would be area of the base times height. When it's a uniform, it's easy. Area of the base, area of the circle would be pi r square, right? This is something that you need to remember. Area of the circle times height. So the volume of the cylinder can be easily retrieved. Area of the base times height. We want to solve for H. Okay. Eddie, are you still there? I didn't see a check mark in front of your name. Armando? There, good. Yeah, okay, good. All right. Who wants to do this problem for us on the board? Who knows how to do this problem, first of all? Check mark if you know how to do this now, by now. So how you solve for h? That should be pretty simple, right? Can you put a check mark in front of your name if you think you know how to solve this? Tamisha? Okay. Tamisha, you want to use your mouse to solve this?
No, I actually don't. I don't know how.
That's okay. Let's see. Who else? Yoli, David, do you want to tell me what would be your first step? Let's do this together.
Do we divide pi r squared on both sides?
Pi squared, you mean, or just pi? Pi
R squared.
Oh, good, yeah, exactly. So the first step is to eliminate whatever attached to this h. Okay, it looks like we have this pi. We can eliminate it by dividing both sides by pi, and we can do the same thing with r squared. Does that make sense? So on the left-hand side, I get v over r squared pi is equal to h. You're done. You did it. Question? Yes, please. Go ahead.
Does it have to be in a specific order?
No.
Okay.
Doesn't have to. Any other question? Okay. I'm checking. You probably hear people are emailing me. I want to make sure that it's not the people who want to log in. So a couple of people are trying to log in earlier. Okay, we're good. Okay, good. Let's see. Let's take a look at another one. Given minus 2x plus 3y is equal to 5, solve for y. Okay. I'm going to ask and pick names now to tell me the steps. How's that? Bobby, you have a microphone, right?
Yeah, I do.
Okay. Can you tell me the first step, please?
Hold on 1 second. I'm writing it down.
Sure.
So first, get rid of the negative 2x.
Very good. Now, how do you do that?
Just divide on both sides.
Divide by what?
Negative 2x on both sides.
Not divide.
Or add, sorry, add on both sides.
Right. That's good. Add 2x. So what do we get on the left-hand side?
3y equals 5 plus 2x.
Right, or 2x plus 5 doesn't matter.
Or 2x plus
and
5.
then what do you do next to solve for y?
Go ahead and divide 3.
Okay, by both sides, right?
Yes.
Okay, good. So y is equal to 2x minus 5. Or can I reduce this?
Yep. Or
Right, good.
no.
That's it.
That's it.
You cannot. That's it, right? You're done.
Yeah.
Good job. All right. Next, and one more. You want to solve question, David? You'll go back to previous page. Yes. Yes. What's the question? Bobby, you want to give the mic away to someone?
Yeah. I think he's asking about the subtraction sign from the 2x minus 5. Is that supposed to be there?
Oh, yeah. Plus, right?
Yeah, addition sign. There you go. Okay.
Yes.
All right, I'm going to turn the mic off.
Plus. Thank you, yeah. Good. Yeah, sometimes you write, doesn't catch there, sorry. Yeah, 2x plus 5 over 3. That was the question, right? Yeah. Okay, next question. We have solve for x. Ax minus 3 is equal to cx plus 7. And Armando, you have a microphone, right? Armando?
What does that say? 8x minus 3 equals what x?
Okay, you're talking about this problem here? C. It's a C.
Okay, thank you.
Yeah, sure. We'll make it better. C. Okay, let's see if Armando would turn up the microphone next.
Okay, there we go. Sorry, I had a troubleshooting.
No problem. Okay, what is the first step?
The first step, I would move the 3 over to the right side, and to get ax plus
like that?
cx, yeah, exactly.
Okay, so let's write it down. Yeah, then you would get
like that, and then that would equal 10 on the other side, and I would cancel out the 3, and then I would divide by
10
x on the right side to get it to the left side.
Not divide. If I divide by x, so you're solving for x, right?
Right.
So what are we going to do?
Not too sure.
Not sure. Okay, that's all right. Let's ask someone else. Margarita. Okay, go ahead. Question, you guys, or comment? Margarita says divide by a. Okay, question, go ahead. Who else got it? Oh, wait a minute. I see students here that have never been here. Talia, were you here earlier? Or you just got here? I didn't see you at the beginning of the session. Oh, I'm sorry. Talia Armanta. Did I say it right? Look, you're typing. You don't have it. We came in a little late. Okay, that's fine. Do you have a microphone, Talia? Okay. Later you can click on Tools, Audio Setup Wizard. You can set up your microphone. That should work. Okay. Make sure you view the recording of this. Those of you who got here late, make sure you don't leave after the session, so you can let me know, otherwise you'll be marked absent. Okay, let's see. Eddie, you want to tell me what's the next step? I haven't heard the correct step yet. Eddie?
I'm not too sure.
Not too sure.
My guess would be divide A to both sides, but then I'm stuck. I don't know. That's just my guess. I'm not exactly sure.
Okay. So let me clear all the check mark for the name. Anybody have idea how to solve this? I'll put the check mark so I can go to you. Eddie, give the microphone to someone who wants to say. Okay, go ahead. Sue? Oh, you don't have a microphone. Go ahead. Just type the answer then. Maybe somebody else with a microphone will give us an idea. If you know the answer, go ahead.
Don't you just subtract?
Subtract what?
AX from CX, and then you get then you get 10 over A minus C?
Let's do that, see what happens. That is one step toward the, going to the right direction here. If I subtract CX, this is what I get. Well, let me ask you, what do you get on the left-hand side, do you think? What do you get?
X? I'm not sure.
Okay, you would get AX minus CX.
Right.
That's what you get, right?
Right. Over 10,
Okay.
right? Or yeah, equals 10?
Equal to 10, yeah. And then I see somebody gave me a correct answer in the chat. Since the X have appear in the more than one place, you see X happen in more than one place. When that happens, you need to factor that X out. Okay? So if I factor the X out, okay. And I see more names here not familiar in the, okay, Marina? I didn't see you at the beginning of this session. Are you there, Marina?
Yeah, I've been here.
I'm sorry.
Yeah, I've been here for a while.
Oh yeah, remember, yeah, you were here. So do you want to tell me how do you factor that? You're right. I got your name earlier.
I'd make it X, and then in parentheses would be A minus C.
Yeah.
You pull the X from it.
So this is what you do. Okay, good. So now, how do you solve for X now?
Can you divide A minus C from that side?
Yeah, you divide both sides by A minus C because that's my coefficient now. So when the X or the variable you're solving for appear in more than one place, you have to factor that, and then whatever you factor, that would be your coefficient, and that's how you solve for X. Okay, I need to see a check mark from everybody's name if you can follow this, please, because you might see this on the next exam and the final exam. So that's how you solve that one. Okay. Somebody asking questions. Who's asking a question? Got it, okay. Let me see if everybody is participating here. Still, Leah. Let's see, over there. Oh, good. Well, except few. Sue, you're there, right? Check mark if you're there. All right. Okay, question anyone so far? 3. Okay, let me pause the session for a second so I can upload the next question. All right, next section talk about the linear inequality in one variable. All the rules that we learned to solve equation applies for solving inequality, except if you divide or multiply by a negative, then you have to change the direction of the inequality to its opposite direction. So you can add, subtract both sides of the equation. You can multiply or divide a positive number to both sides of the inequality or equation. The only time that you switch the direction of inequality will be when you multiply or divide by a negative. And then you also need to know the interval notation as well. So these are the different kind of inequality that you see, like x is less than or equal to 3 means all the numbers that are less than or equal to 3 units. And we looked at this earlier when we reviewed chapter 1, how to graph them. We use brackets because 3 is included. Like if it's less than 3, we use the parentheses here if the endpoint or the number at the end is not included. We talked about this before, so it should be pretty simple. Now, we looked at interval notation. Again, please make sure to review this interval notation. I showed that earlier. You're going to see these kind of problems for the next test and also final exam. In this case, all the numbers that are less than 3, this is how you show them in the interval notation. You open a parentheses, minus infinity, comma 3, and then brackets 3. These are some examples of that. So everyone should be okay with this because we talked about this earlier. Those of you got here late, make sure to review the session. So again, we can add or subtract any number from both sides of the inequality, but if you divide by a negative or multiply by a negative, you switch the direction of inequality to its opposite side. Okay. Now this would be an example of that. So in this case, you add 5 to both sides of the inequality, but when you divide by -2, you switch the direction of inequality to its opposite side it was, and then you graph them and write it in the interval notation as needed. So solving inequality would be very similar to solving equation. That's almost the same. You distribute, you do all those goodies. And again, you don't have to copy this down now because all these examples are in your books. This is example 3 in that section. When you explore the ebook, you should be able to see this in actually with the great detail and the embedded video next to them. So these are the example of solving inequality. Again, if you have a fraction, you do the same thing. You multiply both sides by LCD, or and then you solve them. If you have a decimal, you do the same. You do that. Okay, so application of inequality would be, this would be a good example here. Beth received grades of 97, 82, 89, 99 for her first 4 exams. we want to know what we need to get for the last exam to receive A. If A is 90% or higher, then we set up this equation like average means to add the numbers, divide by number of the terms. In this case, you have 1, 2, 3, 4, 5 exams, so divided by 5. So that's how you would know, divided by 5. And then it has to be greater or equal to 90 in order to receive A. So you just simply solve this for X, and that would be the number you need to receive for that. Okay, let me go back to stop this one here. And it looks like we have some questions here. Yes, what is the question? Margarita? Okay, you're typing. Okay, on the take-home test, Human, can you please do one of the first 5 word problem in the take-home test? Yes. Well, that was my next thing. I wanted to bring that up. So everybody have a copy of the take-home test. Pretty much we covered all the topics that are in chapter R and chapter 1 now, but again, you need to really go back and double check this, look at the ebook, look at those videos. When you look at under the resources, like I said, there are great video lectures for the problems or type of problems that you have a difficulty. You need to explore that between now until next Wednesday. Your assignments for next Wednesday, when we log in, is to print the take-home test number 1, go over chapter R1, make sure you're okay with everything, and then go over chapter 2 as well, because that's what I'm going to explore, chapter 2 in detail. But if you view them yourself, you can ask questions, make a list of your questions. But what I like to do is to go over part of that take-home test number 1 on Wednesday, and then also on Friday when we meet on campus, we're going to look at some of those problems as well. So you should have the take-home test. You ask to work some of these problems out. I really prefer for you to take a look at them first. So let me go back and open up that test that you're referring to. Lecture notes number 1. Okay. So what I like you to do is to take a look at take-home test number 1 first. Do it yourself first, and then view the solution to that, because all the solutions are there already. And then when we meet next time, we'll look at the problems that you might have on that. That would be more efficient than just going over all those problems. So for the remaining of the time, hold on, let me see what else I have up here for you. Okay, let's take a look at some of actual problems for each test. So let me upload this. Okay, so to answer your question, who asked this request? Margarita. So you follow what we're going to do for the take-home test then? You okay with that? You put okay, all right. Got it. Name, yes. Okay, good. All right. Instead, I want to explore some problems that you haven't seen before. That probably, and some of the problems that would be more beneficial to you right now. So let me bring that up. So actually I can open it up here that way, probably it's easier. Okay, this is what we're gonna do. Okay. Some of those word problems that a lot of the students have problem with, I'd like to explore some of that. The one in the take-home test, you have a solution for it already. So let me open a new page here. Okay, everybody grab a piece of paper if you haven't done it already, and write this problem down. We're going to practice some of these together. So this is a very simple one from section 1.2. We want to write twice the sum of a number and 3 equals 14. Find the numbers. Okay. So what I want you to do is use those steps we talked about. I want you to write down what x is, write down the equation, solve the equation, and tell me what would be the answer. So this one here, I want you to put a check mark in front of your name the moment you find what x is. Okay, this is a part of the participation we're talking about. I need you to tell me what x is when you find it. So everybody grab a piece of paper, and you should be able to do this in less than 3 minutes, right? Maybe 4. Okay, I've put the timer here, 4 minutes. Okay, time is up. Most of you are done with this. So I'm going to start the first step here and say, well, step number one, we reading the question, we did it. Step number two is you have to let x equal to something. What does x would be equal to in this case? Armando, what do you call x?
Excuse me?
The first step, we have to let x equal to something. What do you want to call it?
Oh, well, I already solved it.
Okay.
I was going to put...
So the step number one is x would be, you have a lot of echoes with your microphone, sorry. It would be the number, the unknown number then, right? That's what you started?
Yeah.
Okay. Okay.
I'll give it.
So what would be your next step? How do you set up the equation, Armando?
I set it up as 2x plus 3 is equal to 14.
2x plus 3. Okay, it says twice the sum of a number and 3. So the sum of the number and 3 would be x plus 3.
Right.
Marina, you have a question?
And
go ahead.
twice.
Twice would be 2 times. Don't forget the parentheses. Is equal to 14. Okay. Marina, you have a question? Go ahead.
Oh, I was just going to say the equation.
Okay. Is this how you set it up?
Yeah, that's how I set it up.
Good job.
And then
okay, so we distribute. Go and continue then. What did you do next?
Then I distributed and I got 2x plus 6 equals 14.
Uh-huh.
And then I subtracted 6 from both sides and got 2x equals 8.
Mm-hmm.
And then I divided by 2, and then x was equal to 4. And then I checked it, and I did 2 times 7 is 14.
Very good. All right. Okay, so those of you put the X under your name or didn't see how to do this, do you see that now? To make sure you're okay with this? Good?
Yes, I'm good.
Good. All right. So let's take a look at another one similar to this. Let's say we have the sum of 2 numbers is 20. Then we have the larger number is 6 more than the smaller number. Okay, we want to find the two numbers. Okay, that should be pretty simple too. Let's give 3 minutes to do this problem. Okay, starting now. Let's do, I think I did it 2 minutes. All right. Okay, time is up. I see less check mark this time. What's going on? Need more time? All right. Bobby, tell me What did you do first?
Oh, sorry, I wasn't done yet. I'm still working on it.
Okay, I saw a check mark for everything. Okay.
Sorry. Wrong one.
Alrighty, somebody with the mic. Irene? I forgot you have a mic around. Jared?
Well, I know that the sum of two numbers is 20, so let's put x plus x equals 20. But we know that 6 is the first sum, so let x equal, I forget, 6.
Jared, let me interrupt you for a second, Jared. Jared, let's follow those steps. The first step is you have to let x be equal to something and all that. So you want to go let x be equal to what?
20.
I know, but you have to make an assumption first. X is equal to the first integer. Okay? Let x be first integer. If that's the case, then the next, they're consecutive integer, right? The next consecutive integer, wait a minute, sorry, wrong one.
Are they consecutive?
They're not consecutive. Let x equal to, you know what, I was looking at the wrong one. The first number would be the first, actually, you know what, I was looking at the wrong problem, sorry. So the first one would be, let x be equal to the smaller integer, that makes sense. Then the larger one, then the larger number. Okay, somebody tell me what's the larger number then? Equal to what in terms of x? Yeah, in the chat they say x plus 6. Good. Okay, now this is sum of two numbers is 20. The larger number is 6 more than the smaller one. So now the equation would be x plus x plus 6 is equal to 20. So that's the equation that we have. Any question on that so far? Okay, let me ask those people who are not having a check mark in front of their name first.
But when I was there, it was this color. It was this color.
Where is this?
This is illegal.
Oh, okay.
Okay, Bobby?
I believe I got back the house that I was born in.
Okay, I think somebody has a microphone now, I'm not knowing.
It's on this color. I don't think it's crazy.
Okay, so Nasha, Mom, you have your mic on. Did you want it to? No, okay. Okay, can I say check mark from everybody if you're okay with up to this point? Because if you don't, we need to talk about this. Armando, do you follow what we're doing so far? I need a check mark if you do. Kristen? Okay, looks like everybody okay. Alright. Yoli, David, are you okay so far? Okay, so the next step is to distribute or remove the parentheses. You get 2x equal to, I can subtract that, so I get 2x is equal to 14, x equal to 14 over 2, which is equal to 7. So the first number is 7. the next number would be what? Seven plus 6, which is 13. Alrighty. Okay, let's take a look at the next problem here. Okay, let's have 2 minutes to set this up. These are consecutive integers. Go ahead. Okay, time is up. Let's see. Eddie, you wanna tell me how you started this? Okay, Irene, you got the mic. You wanna tell us? Irene, you have the mic. Okay, let's see. Eben, you want to tell me what's your first step? Oh, Eddie, you're there. Eddie?
Yeah, first I got x for the first number. I got x, and then x plus 1 for the second number.
Good. So let x be equal to the first integer, then the next integer.
That's faster than that.
Is equal to x plus 1. Very good. Alright, so how do you set this up?
And then you add those, and you put them in parentheses, and then you distribute the 5.
Okay, so the sum of those would be x plus 1 then, right?
Yeah.
And then it says 5 times that. 5 times that.
And then you make it equal to 705.
December. Very good. So you got 5 times x plus 1 is equal to 705. So I'm going to stop right here and make sure everybody okay with this. Can I see a check mark in front of your name? Okay, that's okay, Irene. I see you had a little problem with your mic earlier. So check mark if you all can follow this. Armando?
Yeah.
Okay, no, I want to see a check mark in front of your name if you follow it.
I didn't put the check. I thought I put the check. I'm sorry.
Yeah, no problem. Margarita, you put the X, so you don't follow this so far. And Margarita says, in what chapter do we find this? This problems here that I'm putting up together would be right now from section 1.2. So if you actually go to 1.2 in your ebook, not only you see these problems, you also see embedded videos next to it, so they can go over the step by step, show you how to do this. Okay? Alright, so the next step would be 2x plus 1 if I add these up. So that should be pretty simple. You distribute, you get 10x plus 5 is equal to 705. You subtract 5. So you get 10x is equal to 700. So divide both sides by 10. So what is x?
X is equal to 70.
70, very good. 70, so the first number is 70. There are, the next consecutive number must be 70 plus 1. So it would be 71. Okay. Question anyone on this? All right. Let's take a look at another one similar to this. Let's give a little bit more time for this one to set up. So let's make this 4 minutes. All right, let's start. Okay, time is up. Ooh. Okay, I see. I see less and less people responding to these answers. Okay, so these are the areas that you guys need to practice between now until next meeting. Once again, you need to open the ebook and look at some of these examples and click on the video lectures next to it. If you go ahead and explore the video per sections, and there's another link called other videos. Those are pretty good too, per topics. So whatever topic that you feel like you're struggling, you need to work on it between now until next meeting. Okay, let's see who can. Armando, are you there? You have a microphone, right? You put the check mark in front of your name. So you want to tell me?
Yeah, I think that I'm not too positive on the first step. Well, I think 6 times the smaller of 2 consecutive odd numbers would be 6x is equal to x plus 2. And then that would be if you
so let me go with that. Let me go ahead and put my other gadget away so I can write down your steps. So the first step is to let x equal to the first
consecutive number.
First odd. It has to be. It's mentioned odd because that makes a difference. Odd.
First odd.
Integer. Okay, sorry, my handwriting, this pen is acting out here. Okay, so then the next odd integer, we talked about this before. So what would be the next odd integer?
Would be x plus 2.
Very good. So if we talk about odd and even integer, let me see if I can go to that page that we talked about odd and just refresh everyone's memory on that part. Okay, we have the page that everybody needed to scroll on it when they got bored. Okay, this is the one, right? So the integers would be 1, 2, 3, 4. If the first one is x, the next one is x plus 1, the next one is x plus 2, and so on. With even or odd integer, if the first one is x, the next one is x plus 2. If it's x, x plus 2. Okay, this is the one, right? That's the page that we talked about before. So odd integers, if the first one is x, the other one would be x plus 2, and so on. Okay, so now we've got our assumptions there based on that. So now we need to fill out the equation. So let's do that. So you're saying that the equation would look like what?
There was 6x equals x plus 2 times 3 plus 33.
Very good. So let's break this down. 6 times the smaller of 2 integer would be 6x, right?
Right.
is equal to, so we write 6x equal to 33 more than 33 more than, so we have to add 33 to something. 33 more than something here. More than what? More than 3 times the larger. So the larger one is x plus 2. 3 times would be 3 times x plus 2. Does that make sense? Okay, what I want to do is I want to stop again and have everybody put a check mark in front of your name if you understand up to this point. But the rest is pretty simple. Okay, check mark everyone if you can follow this, please. Okay, Dalia asking a question says, where can I purchase the ebook? Okay, when you log in in Alex with that financial aid code, they would give you the whole package, including the ebook. You click on the ebook, is there. When you purchase it later, you click on your account. It says extend your account. Make sure to select the one with Alex 360. Okay, Alex 360. That's the one that includes with the ebook. So you have to buy that. I think somebody said earlier you came a little late. Refresh my memory. Is that 11 weeks? The person who find that out, to you have to buy the shortest amount of time, but make sure it's Alex 360. Okay, Leah? Okay, looks like everybody okay with this problem here so far. Okay, let me ask one other question before I finish this. How many of you have a laptop where you can bring it, or tablet, you can bring it to that Friday session? Because the room that we're going to go initially, it doesn't have a laptop or a computer, but later we're going to go to the computer room. How many of you would have, you can bring a laptop to Friday session? Just put a check, just for a survey for me. To see if you can, that's okay, just put X. So many of you have a computer at home only, you cannot drag it to the lab. But those of you who have it, I just want to get a little survey there. Okay, so once you get it to this point, the rest is pretty simple. You distribute, you get 6x is equal to 3x plus 6 plus 33, 6. And then you get 6x is equal to remove the 3x, subtract 3x from both sides, you add these two up, you get 39. You get 3x equal to 39. So this is how you solve for x. X equal to 39 over 3, which is equal to 13. So the numbers they're looking for is 13. They're odd. That's good. The next one would be 2 more than that. 15. These are the integers. Okay, good. So most of you said you have a laptop, you can bring it to the laptop. If you like, if you can, Friday morning, just bring it. If you have a problem with switching your account or any plugins issues, we can use them. If all had a laptop, you could just stay in that. You didn't have to go to the lab. But just bring your laptop if you can on Friday. Okay, question on this, anyone? These are kind of word problems that you need to know for this section. Okay, good. So let's take a look at another one. This is another type of word problem. Let me give you a few minutes to set this up. Okay, once you're done, go ahead and put the check mark in front of your name. Okay, time is up again. Let's see. How are we going to set the equation here? Okay, who wants to tell me with the first step? Okay, Tony, you want to tell me what you did? How do you set up the equation? Hello? Okay.
I put the wholesale amount first.
Okay, so let's come up with the equation. We call here original price, right?
Yeah.
Minus what? What did you put there?
Minus the markup.
Right. So the markup would be 30%. So I'm going to put it 0.3. Okay, so 30% would be the same as 0.3 then. 0.3 of what? 0.3 of the original price. Is this how you set them up? No?
I set it up differently, but I don't know.
Okay, how'd you set them up?
I put I did it like the old one.
So you just did this portion here?
Yeah.
So let's do that part first. So, but we don't know the original price, though. You call it X, right? Is that what you want to call it?
Yeah, put it as X.
Okay, so you put 0.3x, right? That's what you did?
Mm-hmm.
So you put 0.3x equal to 602?
Yeah, basically.
Yeah, well, that's not true, though, right? This amount here needs to be subtracted from original price, which is X. We don't know what it is. So the correct formula would be X minus 0.3x is equal to 602. Okay, so let's make sure everybody follow that first. Okay, can I see a check mark from everybody's name here if you can follow this formula? So mark up or mark down has to come subtracted or added to the original price, so don't forget that. So it looks like everybody get that. All right, so Armando, what do we do next here? How do you solve for X here? So Armando, are you there? Or Tony, you want to continue, Tony, or whoever. Yvonne, you want to say it?
Yeah, I want to say you combine both x's, so you will get 1.3x equals 602.
Very good. So this is 1x times. Did you say 1.3? But these are subtracting. So it cannot be 1.3. 1 minus 0.3, right?
Right.
So what is 1 minus 0.3?
Negative.
It cannot be negative. 1 is larger than 0.3.
What, just 0.3?
0.2 would be 0.5 add up. So 1 minus 0.3.
0.7.
0.7, okay. 0.7x. Now it's easy to solve for x. You divide both sides by 0.7. You get x is equal to 602 divided by 0.7, which is 800. So the original price must be $800. Don't forget the unit. So you should write the original price of the TV is $860. $860. Okay. Once again, can I see a check mark in front of your name if you all can follow this? It seems like a lot of you have a difficulty with some of these word problems. Again, between now until next meeting, you should explore the ebook and those problems embedded and do the pi. The pi would actually help you a lot. But I would suggest to go review the ebook first and then look at the problems under the pi. Okay, so let's see. Do I have everyone here? Jared, you logged out and in. Are you okay?
Yeah, had some technical difficulties.
No problem. Okay, you make sure you review these sessions, whatever you miss. Okay. All right, let's take a look at the next one.
Can you keep this page open?
Oh, you wanna leave this open for a little bit? Sure. Yeah, you can take a look at that. Again,
Thank you.
yeah, sure. So again, it says after 30% rebate, a flat panel TV is now on sale for $602. What was the original price of the TV? So the original price minus the mark down, in this case 30% of X. So you see the X appear in more than one place, and then you solve for X. Okay, let me know when you're done, Jared, so I can go over the few more problems, and then that'll be it for today. Okay, good. All right, let's take a look at the next one. Now, this one here is like an investment problem. It's kind of like that mixture problem I showed you earlier. We have $12,000 to invest here in two different accounts. So I'm going to set them up like I showed you before. So this is one account here, so another account here. So one pays 10.5%. So I'm going to put here 10. Whatever money you put here, give you 10.5%, and the other one give you 12% back interest. So we're going to add these up. At the end, we're going to earn $13.35. So if I invest N dollars or X dollars into this account, my question to you is, how much money do I have left to invest into the other account? Anybody with the mic or type? how much money I have to invest in the other account. Anybody? Okay, Leah, how about you? How much do you have to invest into the other account, do you think? Okay, anybody know the answer? Put the check mark under your name so it can go to you. Eddie typed the answer. The total of $12,000 you have, so you cannot exceed $12,000. So that if you spend N dollars here, so the rest should go to the other account, which should be 12,000 minus N. That's correct. So this is how you set up the equation. So you get 10.5% times N plus 12,000 minus N times 12% is equal to this. So this would be how you set up the equation. So let me ask everyone to put a check mark for the name if you follow up to this point, how to set this up. Check mark if you follow it, please. If not, let me know so we can talk about it. So remember, 10.5% divided by 100 would be 0.105. This would be 0.12. So that's what these are the figures you're going to use. So this would be 0.105 N plus, again, this is 0.12. We can distribute. You get 1440 minus 0.12 N is equal to, then just solve for N basically. Okay, you combine those two, becomes these two would add up to minus 0.015 N equal to, if I subtract 1440, so I would get N, divide both sides by minus 0.15. So N would be equal to minus 105 divided by minus 0.015. So it would be positive 7,000. That would be $7,000. So you spent $7,000 into the first account, and then you subtract 12,000 from that. You subtract 7,000 from 12,000, you get 5,000. That's how much you invest on the other account. Okay, question anyone? How to set the problems? Yoli David, you okay? Let's say check mark in front of your name. You're good. Okay. Okay. All right. Let's see. Take a look at one more. We have time for another one. Okay, this would be a mixture problem. I showed you earlier, very similar. Here again, we can set them up the same way I showed you. You can come up with a couple of boxes like this. Okay, here we get the dietitians need to mix 10 gallons of milk that is 2.5%. So we just come up with, we just write down the numbers. You want to come up with 10 gallon at the end, 10 gallon here, which would be 2.5% milk fat for a patient. And then what we have in hand is we have some milk that mark 4%. So we'll look at this. It's marked 4% fat milk. And we have another one marked 1.5%. We want to mix this to get 2.5%. So what we're going to do is we're going to assume that we're going to have X or N gallons here. So can somebody tell me how much we're going to use for 4% then? Very similar question I asked earlier. Anyone?
Is it 10 minus n?
Yeah, exactly. So the whole thing would be cannot exceed 10, so it would be 10 minus n. So this would be my formula then. So this one is 0.015. This is 0.04. This is 0.25. If I change it to decimal, so that would be my formula. 0.015 n plus 0.04 times 10 minus n equal to 0.25 times 10. You just solve for n. You distribute this, you would get 0.04 times 10. They give you 0.4. Give you 0.4 minus 0.04 n. And then you combine these two, this one and this one, add up to minus 0.025 n equal to, then on the right hand side they get 2.5 minus 0.4, and then you would get n is equal to minus 0.15 divided by minus 0.025 equal to 6 grams. So this would be 6 grams. And then this would be 10 minus 6, which would be 4 grams. Alright, once again, check mark if you follow. This is very similar to, as you see, the investment problems and mixture problem are very, very similar setup. Okay. Check mark if you all can follow this. Okay. I think that should be enough examples as what you need to review for the next meeting. So what I'm going to do now is I'm going to go ahead and cut and paste the attendance here. See how many of you survived the first online session. I do like to hear from you, your comments. From this, the recording session would be available on the same page. As soon as I close this up, would be a link, and you click on it, you can see a recording of this per date. So if you click on today's day on that, you would see the whole thing over again. I like to hear from you how you like these kind of, because this is the first time actually you're offering a course this way. I started my first online class 14 years ago. So I think having a webinar like this, going over the problems in addition to all the resources available, would help you understand the material and move on a little bit better. But let me know your comments, if you like it, what part of it you like it, any suggestions. Email me from class. Click on the inbox in Alex. I'd like to hear from you, so I can adjust my lectures accordingly, make it better for you. And so for next meeting, I would like you to go over chapter R1 and 2, go over the problems from the take-home test, finish the stuff, all the problems under the pie to get familiar with everything. For now, those of you already officially registered for this class, you can leave. Let's say you have a question. Those of you who want to add this class, you can stay, so I can give you a permission number. And before I stop recording, are there any other questions? Any questions at all? Anyone?
How early are the DLA sessions available at LBCC?
Bobby, the DLAs are available in the morning, Monday through Friday. If you can just stop by at Math Success Center, they should have all the information posted. I would have someone to come Friday to our class to talk about that. There are hours as well, but if you can go before Friday to do some of the one that related to chapters 1 and 2, that would definitely help you with the exam. Also, it would give you a point for because you get 50 points for completing the DLAs. You have to do 1 DLA per week if you want to receive that point. So between now to Friday, you should complete 1 DLA. If you want to complete on Friday, that's okay too, but it's the best is to do it before the exam to be more efficient. Okay?
Okay.
Did I answer your question, Bobby?
Yeah, but you didn't tell me what time.
Any other questions? Sure. I'm sorry? Oh, they're open in the morning. You know, I don't know the new time right now, really, but if you go in the morning, I'm assuming 8 o'clock, 8 to 4. Last time I talked to them, I think they were open until 4. But once you go there, all the hours are posted. I haven't received the email from them exact time, but I would post it in class as soon as I get more information. Okay? But any other question, anyone? All right, so I'm going to stop recording. Those of you who are not here today, if I don't see you by next meeting, you'll be dropped from class. You have to attend these sessions every Monday, Wednesday. So if you are not doing anything and you don't respond, you would be dropped by end of that Wednesday session. Okay. Thank you for those of you who participated. I'm going to stop recording and wait for those people to add the class.